Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all of you. We come back to the applied mathematics. We would like to learn on a inverse Laplace transform for this time. In the previous section, we have discussed on a Laplace transform of elementary function and technique of solving problem related to it. This time around, we will do the reverse process, which is called inverse Laplace transform. Since the Laplace transform is one-to-one function, so this process can be reversed such that given the function in terms of s, we can find the function of ft corresponding to this transform. So basically, we have the function in terms of ft, and then we would like to Laplace it, so we get the function of fs. For this time, we would like to transform back the function of fs into the function of ft by taking the inverse Laplace transform. So this is the operator. We call it as a inverse Laplace transform. In previous session, we have introduced to you the table of the Laplace transform, but now we use the same table, but we rearrange back, so that the function of fs is on the left hand side, and then we taking the inverse to the function of fs, so we will get the function of ft. So basically it's the same just like we have learned previously, but for this time it's vice versa. So you can go one by one. If you have a function a over s, so you will get a over here. If you can rearrange in terms of this one, you get the polynomial over here, and so on. We will go one by one. So you no need to memorize, but what you need to do is you just need to understand how to apply this table, how to get the answer from this table. So let's go for the exercise. We will study according to the example. So how to answer the question of here. So basically, the question asks you to find the inverse Laplace transform. So we would like to inverse 120 over s, 120 over s power of 6. So how to do? By looking at the table, so it is under the second row. So the second row. So in the table you will see that if we have 6 n factorial over s n plus 1, so we will have t power of n. So now you need to make sure that your function over here can be represented by this one. So how to represent by this one? So basically what you can do it is, you just need to rearrange how to separate between n plus 1. So it will automatically have 5 plus 1 because it is 6 over here. So what about the numerator here? The numerator must be follow the n. So it's 5 factorial. So you just press the calculator, right? You just press the calculator and check. The 5 factorial will give the answer is 120. So basically, you have this one similar to this one, and this one similar to this one. So it's easy. This kind make it your work easy because you will directly get the answer. What is the answer? The answer is t power of n. So you already rearrange n over here is 5. So this is your answer. This is your answer. Very straightforward. Okay, very straightforward. So this is A equation. Okay, so now let's go to the B equation. So the B equation asks you to inverse 7 over s power of 4. So as I said to you, you need to rearrange. You need to rearrange the denominator so it can be separate between n and 1. So you have s over here, so you must separate it to become n plus 1. So n over here is 3 because of 3 plus 1 is 4. So up to here must be 3 factorial. Must be 3 factorial. However, so look at here, when you are making the benchmark over here, so the denominator is already equivalent, but what about the numerator? The numerator is not equivalent yet. So how to make it this one equivalent? How to make it this one is equivalent? So because of the numerator here is 7, but when you calculate 3 factorial is 6. So how to make it this one? How to make it this one equivalent? So basically, if you want to put 3 over here, so you can make it over here 7 as a constant and 3 factorial over here. So how you need to put the 3 factorial over here? Because we would like to make it the numerator is equivalent to the left hand side over here. So look at here, when we demolish this one, so the equation go to the original equation. So now you can get the answer directly, because according to this one, you will have t power of 3. T power of 3. So this one you can follow, just follow. So we have 7 over 6 over here. So your final answer is 7 over 6 t power of 3. 7 over 6 t power of 3. So this one, what I can say to you is you need to use your own creativity so that you can match. You can match the equation and get directly the answer from the table. Just make it the arrangement. But the arrangement that you need to do is must be equivalent with the original question. So let's go to another question. Another question. So your another question ask you to inverse s over 81 s squared plus 25. So here class, the first thing first, when you get this type of question, you need to look at the table. Look at the table, which one is very close with this question. So I can say to you that how to match this question with the table. Look at here, you have the s, but you have the number over here. By look at the table, you will see that it is under cos 80. S over s square plus a square is cos 80. So let me rewrite for you. If you would like to inverse, with the function of s, we have s at numerator, and we have s squared over here plus with a squared over here. So what you will get is, you will get in term of t is cos 80. So it's similar to this one by look at here. So look at, you have S over here, then you have S over here, you have a number over here. So means that this is the correct reference that you need to refer. Okay, so now you need to use your own creativity. Okay, the tips to get or to obtain the correct solution is look at here. Okay, look at here, class. You see that here the coefficient is 1, and here also the coefficient is 1. So the first thing that you need to do is you need to make sure that the coefficient of S square over here can be 1. Okay, can be 1. Okay, so how to make it the coefficient of S square is 1? So you bring out 81. Okay, let me bring out 81. So I bring out 81. So now the question is, okay, the numerator is remain. Then here we have S square, but here we have 25 over 81 because of I bring out this one. Okay, as I said to you, if you want to modify the equation, you need to make sure that the modification you have made is equivalent with the original one. So basically, this one is the equivalent with the original equation. Why we need to do this modification? Because of using this one. Okay, using the one that I highlight here, you can get directly the answer from the table. So look at here. We have 1 over 81 here as a constant outside. So this one, by referring to this table, so you will see that you will get cos 80. But now you have your A squared over here is 25 over 81. So what about your A? So your A is 25 over 81. So what you will get is, you will get in terms of cos, then A is 5. Okay, so square root 81 will give you, square root 81 will give you 9. Okay, so you will have 5 over 9 t over here. So this is the answer, basically. Okay, so you will get 1 over 81 cos 5 over 9t. Okay. Okay, so let's go to another last example for this time. So you will have the last example over here. The question asks you to inverse. Okay, inverse what? Inverse 1 over 25 s squared minus 81. Okay, so as I said to you, you must refer the table. So which transformation is refer for this equation? Look at here, we have a number over here, we have s squared over here, we have minus over here. We have a number, we have s squared, and we have minus, we have a number over here. So basically, you may refer the inverse of A over s squared minus a squared. Then it will give you sine hyperbolic 80. Sine hyperbolic 80. So now, okay, you need to use your own creativity. The tip is, must the coefficient of s squared must be equal to 1. So you need to modify your original equation. Okay, modify your original equation. As I said to you, you can bring out the coefficient 25 outside over here, and then look at here. Okay, look at here. We have s squared over here, we have 1 over here, we have s squared over here, we have 81 over 25. Since we already bring out 25 over here, so over 25 must be over here. Look at here. Okay, but look at here. You already have your a. You have a squared is 81 over 25. Your a is 9 over 5. But look at here. You only have 1 over here. How to make it 9 over 5 over here? Okay, so 1 over 25. So you just need to have, okay, you need to make your equation having 9 over 5 at numerator. Okay, s squared minus 81 25. So since you want this number as a numerator, so you need to divide by 1 over 9 over 5. Because of basically if you solving this one, it not change the original did not change the original equation. So we have 1 over 25 over here. So this one can directly get from the table by refer to this one. So you will have sine hyperbolic. So you will have 9 over 5t. But don't forget for this one basically, okay, when you change the arrangement, it's similar to 5 over 9, and then you can simplify it. We have 25, we have 5, and then we have 5 over here, right? So it become 1 over, okay, it become what, class? 1 over 45 sine hyperbolic 9 over 5t. Okay, so I hope that you understand how to solve a single function like this. This is very important because all the knowledge that you have learned even for the previous week and this week will be the main reference to solve the ordinary differential equation later on. Okay, so thank you.